In today's video, we are going to see the working and assembly of motorized dough kneader machine. This is an optimized version of my previous machine named as manually operated dough kneader machine. Okay, so in this machine, we are going to optimize our previous machine by removing the handle which is manually operated and using the motor which reduces the human intervention in operating the dough, and it also increases our production and reduces the human effort. So this is the optimized version of our previous machine, dough kneader machine, which is manually operated. So let's see the working of this motorized dough kneader machine. So we will go in motion study and we will play. So let's see. This is our working for the motorized dough kneader machine. As you can see, we don't have to rotate our handle to operate this shaft for mixing of our dough. So let's see which motor gearbox we have used. This is inline type AC induction geared motor, and for specification we will see this is the specification of our motor gearbox. So let me tell you what this denotes. So AS20 is the gearbox product series. This gearbox product series is AS20, and P denotes the foot mounting of this gearbox, whereas 11.67 is the gear ratio of this gearbox, and 071 is the input configuration of the gearbox, whereas B5 and B3 is the motor mounting and mounting position. It denotes motor mounting and mounting position, whereas BE denotes the product series of our AC induction motor, and 71B denotes the frame size of the same motor. Okay, so here 4 denotes the number of pole of our motor, and 230 450 denotes the voltage and frequency. This 2 voltage is different type, one star and delta, and this 50 denotes the frequency of this motor, and IP55 is the degree of protection of this motor. CLF is the insulation class, whereas B5 denotes the motor mounting flange. So this is the data sheet. Sorry, not data sheet. This is the product name. Full name of this product: AS series gear motor. So for further detail, we will see the product data sheet of this motor gearbox. So this is the data sheet. AS type helical inline gearbox, and gear ratio is of 1167. 11.67. So let's see the output RPM of our motor, which is around 1385, and after dividing by 1167 we will get the output of 117 rpm. So at the sprocket we will get 117 rpm, and after the reduction we will get 59 rpm, because I have used 0.5 ratio. Means here I have used 20 teeth, and here I have used 40 teeth. So our reduction will be of 0.5. So our output RPM is 59, as you can see in this video. So this is basically the working and details of our motorized dough kneader machine. So let's see the assembly of this motorized dough kneader machine. So we will start with new assembly. Okay, and first we will insert the ground, which is the base of our dough kneader machine. This is of our ground, and after this we'll insert the stand. This is our stand. Let's hide the unwanted lines and insert our anti-vibration pad, which you can also call as leveling pad. So I will locate this. For this, first I will use concentric mate, and then I will use coincide. By doing this, I have located my leveling pad, or you can see here anti-vibration pad. So let's see the distance between two pillars. Let's see again. It is of 500 and this is of 1230. So we will use linear component pattern to reduce our effort to locate each and to locate at each and every point. Okay, so here we will put 500 as we have seen, and here 1230, and quantity 2 components we will select, and okay. Let's see what problem we have. First we will delete this again and do the same procedure again. First select this and then this, and then we will select our product and then okay. So now everything is okay. So two positions are also remaining. So in that we will do the same procedure as we have done at this point. So we will take one anti-vibration pad, locate it by using concentric mate, and then we will give coincide mate. So by doing this, we locate on this also, and we have remained with this pillar. So at that, we again do local pattern and select. No, in this we don't do. We have to use new linear component pattern. So first we will select the direction. Sorry, and then we select our product. So by doing this, we have made our starting point, and then we will locate this stand on our ground. First we will do the width mate, and by doing this we have located our stand on the ground. Okay, so we have located our stand on the ground. Now let insert our motor. So our motor, this AS20 series, first we will give coincide mate at its location, and then we will give concentric mate. Again we will give concentric mate to another point. So we have located our motor gearbox. Now we will insert our UCP 206 bearing. So let's see. This is our UCP 206. So we will point it its position. First we will give coincidement and then center in slotment. As you can see here is slot type, and we will do the same for the other position also. So this is how we locate UCP at this point. Now we will do the same at another position also, which is here. So I will rotate this. Okay, and now do the same procedure as I have done previously. Center in slot. Okay, again slot, and this is how it is located. Now it's time to add our box, bottom box, and UCF bearing 206. So first we will give the coincide met, and then we locate the center. Okay, now the mounting position we locate, and this is how the UCF 206 mounted on our bottom piece. Now we will take one again. Let's rotate and do the same procedure as the previously I have done. Coincide, locate at its center, and locate the mounting position by using concentric mets. So this is how we located our bottom piece of this dough kneader machine. So we will rotate this dough kneader. Okay, now we will insert our shaft. Let's see, is the shaft. So this is our shaft, and now we will rotate this shaft because this position we want at this side. So we will rotate. As you can see, I have previously told that this is not a single part as we are inserting in the SolidWorks, but in practical we are going to nut bolt these plates with the shaft. So it will be done after inserting in the box this bottom piece. Okay, so let's locate by giving concentric met. Okay, so this we have located. Now we will give concentric met with the UCP bearing, and first we will locate this bottom box by using width met, and okay, and after that we'll give coincide met to this shaft. Okay, now you see the shaft is also located and the bottom box is also located, but as you can see there is degree of freedom in this bottom box. So for locking this degree of freedom, we will insert one knob which we can say as handle. So this will reduce the degree of freedom, reduce, or you can say lock this degree of freedom. So we will give concentric mat with this, and as you can see, this bottom box is totally locked. Now we will insert our sprockets. So these are the two sprockets. One is of 20 teeth and of 08B series with 20 ID because motor diameter is 20. So I have selected this. Let's rotate and locate at the motor position, motor gearbox position. So first we will give concentric mat, and after that we will give width mat to the keyway with the key of the motor gearbox, and after this we will give coincide mat with shaft, not with the motor. We will give with the shaft because there will be minor error. You see, 0.2 mm we have difference. Okay, so this we have added sprocket of 20 teeth. Now it's time for shaft sprocket, which is of 40 teeth and 08B series. Let's rotate and locate on the shaft. So first we will give the concentric mat and do the same as we have done with the motor gearbox. Width mat, okay, and coincide with the shaft. So this is how we located our sprocket 2. But as you can see, if I will give width mat on this, we can't rotate this. So first we will delete that width mat because if we don't delete, we can't rotate our sprocket. So let's delete that and give one gear mat to this sprocket. So we will go in mechanical gear mat and we will select the top surface of sprocket 1, top surface of sprocket 2, and give the gear ratio 20, and here is 40. So okay, now let's see how is the rotation. So if I am rotating this in clockwise direction, sprocket 2 is rotating in anti-clockwise direction, as practically it will not going to happen. So we have to edit that mate. So we will edit feature, sorry, it is suppressed, edit feature, and we will do the reverse and okay. So let's see again. Okay, now it is rotating in the same direction as the sprocket 1. So let's go for the next step, which is insertion of the top box. This is our top piece. So we will locate it its position. So first we will give coincide and then we will give width mat, and this is how we locate our top box with our bottom box. Okay, but as you can see, anyone can remove this top piece. So locking this top piece, we use one latch. So let's insert that latch also. So this is our latch. So first we will give coincide mat, and then we will give concentric mat, and this is how our latch one got located. So it got opposite. So we will remove all the mats and do the same procedure again. Okay. So first coincide and then concentric, and same for this. Okay. So our latch one is located, and we will do the same for the opposite side. Rotate it, and now relocate it. First we will give the same as the previously, which is coincide made, and then we will give concentric made, and this is how we have made our dough kneader machine. So the covers we have shown in the main assembly. We are not going to show here also here, because this will take time and it is not necessary. If you want, you can give that. I am just doing the for your understanding. Okay. So let's see the final step, which is of motion study. So let's see how we will give our motion study. So you start motion study, and we'll select this motor and give it to our sprocket. So this is our rotating part, and we will give speed of 117, as we have seen in the product data series of the motor gearbox. And we will say okay, and we will get the timing, but we will increase this time to 10 seconds. Okay, so let's play. As you are saying that the kneading process is successful. Let's see again. Okay, so this is the working of our dough kneader machine. So this is how we have done the working and assembly of our dough kneader machine. We have used cover for the protection from the moving parts. In this, we are not using that cover, but you can use the cover if anything is movable, because it will be injurious if you will not use the cover in this assembly. So I am doing that only skeleton model for understanding. But if you are going to make this model, please make that cover which I have shown you in the assembly. Okay.